Okay, let's do a very simple limit proof using the epsilon-delta definition of the limit. So I'm going to take just a very simple limit here that we all know. Let's say I want to know the limit as x approaches 2 of 4x plus 1, and of course we know that limit is 9. But I'm going to prove using the epsilon-delta definition. Okay? So that's the idea. Prove it. Show me that this statement is true. In other words, we need to prove that given any epsilon, some small positive number, we can find another small positive number delta, so that if x is within delta of the number 2, x is close to 2, when these guys are close together, if this is true, then these guys are close together. These guys are within epsilon of each other. Then the absolute value of 4x plus 1 minus 9 is less than epsilon. So this is what we need to prove, okay? Okay, so here's what we're going to do. While nobody's looking, we're going to do some work on the side to sort of find a delta. Now, the key here is epsilon is not a specific number. It could be any arbitrary number, so we're just going to refer to it as epsilon, okay? It could change. The idea is no matter what somebody chooses for epsilon, we can choose a delta in terms of the given epsilon that makes this a true statement. Okay, so while nobody's looking, what we're going to do is we're going to learn about epsilon, and all we know about epsilon is that we need this statement to be true. So what we're going to do is we're going to isolate that guy and learn about epsilon first. This is just side work. This is not the proof. We know this needs to be true, and we'd like for this statement to make this true. So I'm going to keep this in mind just off to the side here. My absolute value of x minus 2 has to be less than delta, and that should make this a true statement. So let's learn about epsilon. So if I simplify this, I get 4x minus 8 is less than epsilon. And I notice now I need an x minus 2 in this statement, and I could easily get an x minus 2 over here by factoring out a 4. Furthermore, I have the absolute value of x minus 2. Luckily for us, 4 is a positive number, so I can pull it out of the absolute value without changing anything here, and I have an equivalent statement, but my 4 is outside. So what I can do now is divide both sides of this inequality by 4, and look what I have. The absolute value of x minus 2 is less than epsilon over 4. Notice that if I start with this and then multiply by 4, I'd get this, and then put the 4 back inside the absolute value, I'd get that, and if I distribute that 4, I'd get this, and if I rewrite negative 8 as 1 minus 9, I'd have this. So if I know this is true, then I know this is true, and that's exactly what I want to prove, okay? Alright, well, we sort of hit the jackpot here, because I'm going to choose the delta to equal this epsilon over 4. Because if the absolute value of x minus 2 is less than epsilon over 4, which is what this says, then I already know that implies each of these statements, which implies what I want the conclusion to be, which is this. Okay? And I'll just make a little note here, or something smaller. Right? This is the biggest epsilon I could choose, but I could choose something smaller, like, for example, epsilon over 8. Epsilon over 8 is still a positive number, but smaller than epsilon over 4. Okay, so this was just our side work that nobody saw. This was us learning about epsilon to get a delta. So we're going to now show that this delta will make this a true statement and that will be the proof that this is the limit of 4x plus 1. Okay, so now we're given epsilon. This is the actual proof, so let me label it actually. We've done our homework. We know how to pick a delta, so now we're going to prove this statement using the delta that we chose. So the proof. So give me epsilon. I choose, sorry, there should be more of a space there. I choose delta to be whatever epsilon you give me. I choose delta to be that epsilon divided by 4. Okay? So now this thing says if this inequality is true. So I'm going to assume that's true because I'm allowed to. It's in this statement it says if this is true, so I'm going to assume that's true. Assume the absolute value of x minus 2 is less than delta. In other words, we already know delta is epsilon over 4, so in this case the absolute value of x minus 2 is less than epsilon over 4, which is our delta. Then I want to conclude this statement. So what I can do is go through those steps that I had here in reverse. So I'll multiply both sides by 4, which gives me epsilon on the right. I can inject my 4 into my absolute value. It's a positive number. That's not going to affect the absolute value. Distribute my 4. And then I'll rewrite my negative 8 as 1 minus 9. And there we've done it. I've proven that this is a true statement, assuming that this inequality is true with the delta we chose, and I chose my delta to be equal to epsilon over 4. So that's the end of the proof, and usually after you prove something you make this box and you fill it in to signify that your proof is done. It always feels good to write that. So there we go. We were given an epsilon. I know that for this particular limit, if you give me epsilon, all I have to do is choose my delta to be that epsilon divided by 4, and that will make sure that if x is that close to 2, then 4x plus 1 will be that close to 9.